phase transitions video number 3. By the end of this video, you will be able to calculate the change in energy during temperature and phase transitions. You should have with you your video number 3 worksheet, a calculator, and a pencil. As stated, there's two types of energy calculations we're going to do. One is with the temperature change. The formula for this is Q equals mc delta T. Now, what do these letters mean? Q is your heat. The answer is going to end up being in joules when you are done. M is the mass. Delta T here means the change in temperature. And C is the specific heat. Specific heat is a variable that is given for each different type of substance. For example, for water, specific heats are as follows. As you can see, there's one for liquid, which is 4.184 joules per gram degree Celsius. There's a separate one for solid and a separate one for gas, which means a different amount of energy is required to make the temperature go up for 1 gram and 1 degree Celsius. Now, I specifically did not put down the units for the mass and the change in temperature. This you're going to have to look at whatever your specific heat variable says, which is given. And since this one is given in grams and degrees Celsius, my mass up here should be in grams and degrees Celsius. But if it was in kilograms or Kelvin, you would use those units instead. The other formula you should know is the one for a phase change. This formula is Q equals delta H times by N. Once again, Q is going to be the heat. N is the number of moles. This is similar to back during the gases time when we had PV equals nRT. N was the number of moles then, and it still is. Delta H is your change in enthalpy. As in the specific heat time, this would be given to you because each substance has its own delta H. As you can imagine, it's much easier to get oxygen to evaporate and become a gas than it would be for aluminum metal. There's going to be two different constants given for any substance. For water, the constants are as follows. Notice the F and the V. The difference is this one is for vaporization. So is whenever you talk about liquids going to gases, or vice versa. And the other one is for fusion. Fusion is when things come together. So it is for a solid going to a liquid or vice versa. Now, I didn't put the units up here again because you're going to have to look to see what your delta H value is. This is always given. Since this is in kilojoules, the unit will be in kilojoules. And it's the number of moles, and there you have the number of moles. So let's try two problems in action. The first one, determine the energy change when 150 grams of water at 25 degrees Celsius is raised to 125 degrees Celsius. First, you need to know what is happening. A good way of looking at that is a graph. So we're going to do temperature, and this is the time the reaction went on. And we're starting at 25 degrees, and we're going to go to 125. Now, since this is water, and we know water is going to have a normal boiling point of 100 degrees Celsius, that's where the phase transition is going to occur. So we're going to start off increasing our temperature, then we're going to have the phase change, then we're going to increase the temperature again. So we have three main sections. Each slope is a different process that's occurring in a different formula. In here, we have a liquid. Then the liquid went to a gas because we are boiling, as we said over here, and then we're going to be a gas. we're going to have 3 different formulas. Now, as I said, they will always give you the variables that you need. You're just going to have to be able to figure out which one is appropriate at the time. Let's start off by doing the step 1, then we'll do section 2, and then we'll do section 3. Okay, in section 1, we have a temperature change. So we're going to use Q equals MC delta T. And we're going to plug in our mass. Specific heat is going to be for liquid water because we're in the liquid state. And the temperature change, delta T, it went from 25 to 100 because we didn't get the whole way up. So it's 100 minus 25. So Q ends up being 47070 joules. Stage 2. In stage 2, the liquid is going to a gas. It's plateaued. No temperature change. So the formula is Q equals delta H times by N. But we need to figure out which H is appropriate. We're going from liquid to gas, so that's vaporization. So I'm going to use the heat of vaporization. Now notice how I have moles and to plug in, but I have my grams up here. So you're going to have to calculate what your number of moles is for your water. We've done these problems in the past, and you use the molar mass to convert in the periodic table. And we have about 8.32 moles. Okay, a good best practice would be for you to stop, try stage 3 on your own, and then double check your work. Okay, on stage 3, Q equals, temperature change is increasing, so we're going to do the MC delta T formula. We have our mass. We want to stop and see which specific heat works. In here, you're in the gas phase, so I'm going to use the gas one. So I'm switching to the 2.02 number. The delta T, I went from 100 degrees to 125. So final minus initial. And when you're done, Q equals 75 joules. Up here, when we multiplied, our number was 339 kilojoules. Okay, so the question is, what's your temperature change? So, what's your energy change when it goes from 25 to 125? We know the temperature change for each individual step. You will want to add these together to get the overall answer. But notice how right here, I'm in kilojoules. For the other two, I'm in joules. So whereas in the past, you're going to want to convert them so they're all matching units. Since 1000 joules equals a kilojoule, that means 47 kilojoules here, and down here, 7.6 kilojoules. So my overall answer is the 47 kilojoules plus the 339 kilojoules plus the 7.6 kilojoules. Give me a grand total of 393.6 kilojoules for my final answer. In this case, we were absorbing energy. We expected it to be endothermic, and we expected to get a positive answer as we did. Okay, second and last example problem. Determine the energy change when I'm going to use the same 150 grams of water at 15 degrees Celsius is lowered to -10. Okay, a good best practice would be for you to stop the video and draw the graph that shows what this is going to look like, and then we'll double check your answer. Okay, you should have drawn a graph with the temperature versus the time. In this case, I'm going from 15 to 10. So I want my 15 degrees Celsius here, and my negative 10 degrees Celsius down here. The phase change in this case, since it's going from liquid range to solid range, is going to be the melting point. The normal melting point is 0 degrees Celsius. So I'm going to put that on the graph. I'm going to lose energy as I lower my temperature. I'm going to plateau during my phase change, and then I'm going to go down again. So this one also will be a 3-step process: liquid, liquid to solid, and solid. I'm going to call it step 1, step 2, step 3. Okay, as before, a good best practice would be to stop the video, try the problem, and then double check your work. Okay, step 1. Step 1 is a temperature change. So Q equals MC delta T. I'm going to put in my values. Notice that my C is in the liquid phase, so I want my liquid variable. And then the temperature change went 15 to 0. So final minus initial. And my Q value when I'm done is negative 9414 joules. Negative, because 0 minus 15 is going to be a negative 15 number here. And negative because I am going downhill and I am exothermic. Okay, step 2. Since I'm in a phase change region, I want my delta H times by number of moles. Delta H, I want to make sure I select the correct one. Liquid to solid is fusion, so I'm going to use a 6.02. And then multiply that by the number of moles that we had on the previous screen. And you should get a number of 50 kilojoules. Now the problem here is that these numbers here are used for going solid to liquid and liquid to gas. So unlike in number 1, you need to figure out the phase change and you need to figure out if it's a positive or a negative value. Since I'm becoming the solid, it's going to be a negative. And the third step, which is also a temperature change, but in the solid phase, gives me a negative value of 3090 joules. Now to find your overall value, you want to add these together, but notice the kilojoules here, so I need to convert the others into kilojoules. This will become negative 9.4 kilojoules, and this one is negative 3.1 kilojoules. So your overall answer, negative 9.4 plus negative 50 plus negative 3.1 gives me an overall value of negative 62.5 kilojoules. So the trick is break it up into the different stages, make it visible on a graph, and then double check which is the correct formula and the correct variable to use.